Alright class, so the last couple times I've been talking about Lewis structure, and I gave you the rules last time to draw Lewis structure. Basically, Lewis structure, when you have two nonmetal, when you have covalent compounds, there's no balance of charges, there's no charge attraction, there is sharing of electron, and Lewis structure will show how they are sharing electrons. And you had two take-home problems, right? You had two take-home problems. Hopefully you did it. I give you the rules last time. You might have learned a different way in high school, but go by my rules. My rules are good. I say they're good because they're my rules, but they usually get you the right answer. So, rule number one, what you had to do is, so these were the take-home problem. The first thing you had to do is figure out the number of valence electron. For BH3, the number of valence electron is, BH3 has 6 valence electron because boron has 3 valence electron, hydrogen 1, together would be 6 valence electron. The first atom, excluding hydrogen, goes in the middle, so boron is going to go in the middle. The better way of saying that is the least electronegative atom goes in the middle is usually the first atom. So the first atom goes in the middle, then I'm going to put hydrogen, hydrogen, hydrogen around it. Doesn't matter how you put it around it, just put it around it. Then you're going to draw a bond between the center atom and the surrounding atom. Then you're going to draw a bond between the center atom and the surrounding atom. So far, so good? Okay. Now, remember, each covalent bond has 2 electrons. Each covalent bond is sharing 2 electrons. So how many electrons have I already put down? 1, 2, 3, 4, 5, 6. So we've already put down 6 electrons. Because remember, valence electrons are involved in bonding, right? Valence electrons are involved in bonding. So I have to account for 6 electrons that are being involved. Okay, I have no electrons left. Oh boy. Now, let's see if my surrounding atoms are happy. Is hydrogen happy? 1, 2. Yeah, hydrogen is an exception. Hydrogen is happy with 2, right? Yeah. So hydrogen happy, hydrogen happy, hydrogen happy. Now I go to my center atom. Is my center atom happy? 1, 2, 3, 4, 5, 6. It has 6. Before you say no, because it needs 2 more, I need you to remember the exception. We said everyone would like to have 8 electrons. Everyone wants to have 8 electrons, except hydrogen is happy with 2 electrons and boron is happy with 6 electrons. Because remember that? We said hydrogen and borons are not greedy. They do not want to have octet. They're happy with 2 and 6. So is boron happy here? Boron is happy here. So I am done, and all the electrons that I counted for. Good? Okay, beautiful. The next one I asked you was PF5. Okay, number of valence electron for PF5 is, it has 40 valence electron. Okay, because if you look at the periodic table to see how many valence electron, it shows you the valence electron, the group number. Group 1A has 1, group 2A has 2, the oxygen group group 4A has 4, the nitrogen group has 3. So it just keeps going on. 5, and it keeps going on like that. Okay, and just because I just confused the heck out of you, let's just go over this one more time. So fluorine is in group 7A. That means it has 7 valence electron, but I have 5 fluorine, so it would be 7 times 5 would be 35. Phosphorus is in group 5A, so that would be 5 valence electron. 35 plus 5, that would give me the 40. I'm going to write it down just in case if someone's forgetting the valence electron. So that one has 7, but I have 5 of them. Together would be 40 valence electron. So far, so good? Okay. Now, the first atom goes to the middle. Then what I'm going to do, I'm going to put the fluorine around it. Doesn't matter how you put it around it. Just put it around it at the beginning, right? Now, draw a bond between the center atom and the surrounding atom. And we said that each covalent bond shares 2 electrons, right? So how many I have already put down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have already put down 10. I have 30 electrons left. I have to make sure my surrounding atoms are happy. Is fluorine happy? No, it has 2. How many more does it need? 6. How about this fluorine? It has 2, needs 6 more. This fluorine, it has 2, needs 6 more. This fluorine, it has 2, needs 6 more. This fluorine has 2, needs 6 more to have 8. So each fluorine is going to have 6 more, so they would have 8 because everyone wants to have 8 to have an octet, to look like a noble gas. Okay, so how many have I already put down? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I know there was a better way of counting that, but I wanted to do it the long way. So I have no electrons left, but my surrounding atoms are happy. Now we're going to go to the center atom. How many does the center atom have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What? Is that okay? It has 10 electrons, so it's more than happy. Now, that was another exception, if you remember we talked about. We said everyone wants 8, okay? We said everyone wants 8. But it's okay to have more than 8. It's okay to have more if you are a third row and below, as long as you are not on a second or the first row. So it's okay to have more as long as you're not on first or second row of the periodic table. So that was another exception. We said everyone wants 8, okay? Everyone wants 8, but once in a while, they might have more than 8. And if you have more than 8, it's okay, as long as you're not on a first or second row of the periodic table. And phosphorus is not. Phosphorus is on the third row. And we explain why that is. You can go to the other video to see why that's okay. So because they have the empty d orbital. Okay, so yeah, it's okay. It has more than 8. It prefers 8. But if you have more than 8, you can be extra happy. That's okay, because this one is on the third row of the periodic table. It's not on the first or second row. So far, so good? Okay. So the reason I gave you these two problems, I want to go over all the exceptions. So all the exceptions is out of the way. Now, let's do more practice problem. There's one more thing I want to show you a little structure, but let's do more practice problem. All right. Ni3. Again, the first is the same thing as before. You have to figure the number of valence electron. Iodine is in a halogen group, so it has 7 valence electron, but I have 3I, so 7 times 3 is 21, and nitrogen has 5 valence electron, so together they would have 26 valence electron. The first atom goes in the middle, okay? Now I'm going to put the I around it. Doesn't matter how you put it around it, just put the I around it. You can decide later with the geometry. Draw a bond between the center atom and the surrounding atom. Draw a bond between the center atom and the surrounding atom. Okay, now we said that each covalent bond has 2 electrons. It's sharing 2 electrons. So how many have I already put down? 1, 2, 3, 4, 5, 6. So I've already put down 6. 26 minus 6 is 20 electron. Use a calculator, even easy math on the exam. You'll be surprised how you would mess up the easy math. I would do the same. Now we have to go make sure the surrounding atoms are happy. Is I happy? No. It has 2. How many more does it need? 6. I happy? No. It has 2. Needs 6 more. Same here. Has 2. 6 more to have the octet. To have 8. It needs 6 more to have 8. Okay, that's good. So I just put down 18. I have 2 electrons left. Now my surrounding atoms are happy. Now, whatever is left, now I have to put it on the center atom. Now I have no more electrons left. Now we said when you put it on a center atom, because this one is not involved in the covalent bond, you put a little circle around it, and this is called lone pair. Now let's see if this the center atom is happy. Hopefully it is. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it is. So nitrogen is also happy. Yay. All right. So we said you can just put them around the nitrogen however you want, but I also taught you the correct geometry. Once you draw the Lewis structure, then you can go to our geometry sheet and decide what geometry this one would have. What is the correct geometry? We talked about Vesper geometry, and the way that the scientists put the Vesper geometry together and proved it later on was that the atoms are as far away as they can from each other. Because when they're far away from each other, less repulsion, they are happy. So look at that sheet to see what is the geometry of NHI and NHI3. I'm going to put it up also. What's the geometry? What do you think? So if you look at here, there's my center atom. There's 3 bonds around it, and the center atom has a lone pair. Center atom, 3 bonds around here, and the center atom has a lone pair. This alien thing is a lone pair. Pyramidal. So the geometry is pyramidal. So that would be the correct way of putting the eye around it. This would be the correct geometry. At the beginning, you can draw it however you want because you don't know what the geometry is. You can put the eye here, here, and here. You can put it on top. Do however you want. But then once you draw it out, then you can go to this sheet and see what is the correct geometry and redraw it based on the correct geometry. Pyramidal. So far, so good. Okay. Next one. SiBr4. Again, the first thing you have to do, you have to look at the number of valence electron. Br again, a halogen. It has 7 valence electron. I have 4 of them. That's 28. Si has 4 valence electron. It's in the group 4A. So what I have 32 valence electron all together. So far, so good. Okay. Now, the first atom goes in the middle. I'm going to put Si over here. Now the Br is going to go around it. Okay. Then I'm going to draw a bond between the center atom and the surrounding atom. Okay. Hopefully you're getting used to this. Now each covalent bond has 2 electrons. They share 2 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. I've already put down 8. Okay, so 32 minus 8, that's 24, I think. Yeah. All right, so I have 24 electrons left. You have to make sure the surrounding atoms are happy. Each Br has 2 electrons. You need 6 more to have 8. So I'm going to put 6 more around each one. Okay. All right. So now it's great because my Br is happy. Each one is going to have 8, 8, 8, 8. So my surrounding atoms are happy. But how many did I already put down? What do you think? You put down 1, 2, 3, 4 times 6 is 24. So you put down 24 electrons. You have no electrons left. Now let's see if my center atom is happy. 1, 2, 3, 4, 5, 6, 7, 8. The center atom is happy. So I am done. And the very last rule was if you had no more electrons left and the center atom was not happy, that's when you make double bond and triple bond. But here, I have no more electrons left. Yeah, but the center atom is happy. 1, 2, 3, 4, 5, 6, 7, 8. So I am done. What is the geometry? Let's go over here. So again, you have a center atom. This center atom has 1, 2, 3, 4 bond, and it has no lone pair on it. What's the geometry? Tetrahedral. Tetrahedral is the geometry. And one more time, I know you may look at this geometry and say, oh, are you sure this is as far as they can possibly get from each other? Remember, this paper is 2D. Reality is 3D. So this may not look like these are so far away from each other. But if you make a 3D model, you see that, yeah, this is as far as they can possibly get from one another, which means less repulsion. Okay, one more practice problem. How do you feel about this? One more, yeah? Okay, let's do one more. SO3. Pause me, do this, and then unpause me. All right, number of valence electron. You have 3 oxygen, and oxygen has 6 valence electrons in group 6A. And then sulfur also has 6 electrons, is in the same group as oxygen. So you have 4 valence electron together. Now, what goes in the middle? Sulfur is going to go in the middle. I'm going to have oxygen, oxygen, oxygen. Doesn't matter how you draw it. You can draw it however you want at the beginning. Okay. Now, in each covalent bond has 2, it shared 2 electrons. So how many have I already put down? 1, 2, 3, 4, 5, 6. I have already put down 6. 24 minus 6 is 18 electrons left. Now I have to make sure my surrounding atoms are happy. Is oxygen happy? No. It has 2, needs more, 6 more. This oxygen, same. Has 2, needs 6 more. Has 2, needs 6 more. So what I'm going to do now, I'm going to give it this 6 electrons that it needs, 6 electrons that it needs, 6 electrons that it needs. We're good so far. So then oxygen is happy, oxygen is happy, oxygen is happy. And each one has 8, each oxygen. So how many did I add? 6, 12, 18. Okay, so I added 18, which means I have no electrons left. Is my center atom happy? 1, 2, 3, 4, 5, 6. The center atom is not happy. Remember what we talked about. If you have no more, If you have no more electrons left and the center atom is not happy, that's when you make double bonds and triple bonds, because I have nothing left and the center atom is not happy. Now, 1, 2, 3, 4, 5, 6. I have no more electrons. It has 6. It wants 8. So it wants 8. It has 6. So it needs how many more? It needs 2 more electrons. If you need only 2 more electrons, how many bonds do you need? That means you need 1 more bond, right? You need 1 more bond because each bond has 2 electrons, right? Because each bond shares 2 electrons. And if this one needs 2 more electrons, that's 1 bond. So I need to make 1 double bond. How am I going to make the 1 double bond? Doesn't matter. Doesn't matter which oxygen I make it from. It doesn't matter. I want to make it from this oxygen. I'm going to take those 2 and make a double bond. So it would be S double bonded O, O, O. Make sure you don't change the rest of these, right? Okay. So those 2 electrons in green are now here. All right. Again, remember, these 2 electrons are now here. These 2 electrons are now here. I can't even draw it out. So these 2 electrons are now here, right? Okay. All right. So this is and then is sulfur happy now? 1, 2, 3, 4, 5, 6, 7, 8. Now sulfur is happy. Everyone has 8. Now, you may ask me, could you take the lone pair from this oxygen, make a double bond? Sure, you can make a double bond here. You can make a double bond here. You need only 1 double bond because you only need 2 more. So don't make 3 double bonds. Don't do that. You need 2 more electrons, so you only need 1 bond. But you could also, don't take it from here, take it from this one or take it from this one. It doesn't matter because this is a symmetric molecule. You can just flip it. If you flip it, all the things will be the same because it's all oxygen. You can just keep flipping it, you would get exactly the same molecule. So it doesn't matter which oxygen I take the electrons from, as long as you make 1 double bond. As long as you make 1 double bond. And I've seen on Google that there's someone that they make 3 double bonds. You don't need that. You need 2 more electrons, you make 1 double bond in this class. So far so good? Okay, what is the geometry? So I have a center atom, and it has 1, 2, 3 things around it. And if you remember, we said the geometry, the double bond and the triple bond, they do not change the shape for VSEPR geometry. The double bond and triple bond, they change the bond lengths, which we're not going to get into it right now, but it doesn't change the geometry. So what would be the geometry of this? So here, S has no lone pair on it. It has 1, 2, 3 things on it. So that would be trigonal planar. So this would be trigonal planar. Again, I am not going, you don't count. Basically, the double bond and triple bond doesn't really change the shape. So here I have sulfur, center atom, no lone pair on it. 1, 2, 3 things around it. And then that would be trigonal planar. That would be trigonal planar. All right, good practice problems, huh? Good practice problem. Nice job. Okay, there is one last thing I want to talk about Lewis structure, and then we can move on to the last part, which is polarity. The last thing I want to talk about is drawing Lewis structures. Drawing Lewis structure for hydrocarbons. Let's talk about what is hydrocarbons. Hydrocarbons are molecules that are made of nothing but a number of carbon and a number of hydrogen. So they are made of nothing but hydrogen and carbon. Okay, they're made of nothing but hydrogen and carbon. X is some number of carbon, Y is some number of hydrogen. So hydrocarbon is almost in a name, right? Hydrocarbon. They're made of nothing but hydrogen and carbon. Now, what are we used for? Hydrocarbons are used for fuel. Any type of fuel that you use is usually hydrocarbon. So, what do you put in your car to drive your car? Gas, okay? Actually, gas is hydrocarbon. So you put in hydrocarbon in your car to drive. So next time, instead of saying, I need gas, I need to go get gas for my car, what you could say, to sound intelligent, you could say, oh, I need some hydrocarbon. I'm going to go get some hydrocarbons for my car. Totally kidding about that. Don't say that. People think you've lost it. But hey, it's going to make you sound very intelligent. So think about that. When you're getting gas, you're getting hydrocarbons. And hydrocarbons are compounds that are made of nothing but carbon and hydrogen. Now, one thing I need you to remember, this, because if you go to 30B, Chem 30B, or if you go to O-Chem, this is going to come handy. Remember that carbon makes 4 bonds and hydrogen makes 1 bond. Highlighted, put a circle around it, put a star around it. I need you to remember that carbon makes 4 bonds and hydrogen makes 1 bond. Carbon makes 4 bonds and hydrogen makes 1 bond. I need you to remember that. Okay. Now, the first one we're going to do, we're going to draw a CH4. CH4 is a hydrocarbon, is made of carbon and hydrogen. Okay. Now, when we draw a Lewis structure for hydrocarbon, I'm actually not going to count electron. That's what I wanted to show you. There's a better, funner way to do this. So carbon goes in the middle. Okay. And I'm going to put the hydrogens around it. Carbon needs 4 bonds. How many bonds does carbon have right now? 1, 2, 3, 4. I'm done. It's a kind of a fun way of doing this, okay? Now, what is the geometry? Carbon has 1, 2, 3, 4 things around it. Look at the geometry sheet over here. That would be tetrahedral. Okay, ready? Let's do another one. You want to do C2H6, okay? C2H6. Hey, I'm not going to count the number of things. So you put CH4, I'm not going to count the number of atoms like before. So I have 2 carbons. What are you going to do? You're going to attach the 2 carbons together, okay? Attach the 2 carbons together. I have 6 hydrogen. So each carbon would get how many hydrogen? Each carbon would get 3 hydrogen. Okay. How many bonds does each carbon have? 1, 2, 3, 4. 1, 2, 3, 4. Each carbon has 4 bonds. I'm done. Each carbon has 4 bonds. That's really, really key. 1, 2, 3, 4. 1, 2, 3, 4. Each carbon has 4 bonds around it. I am done. This is the structure of C2H6. Okay. Now, hang in there with me. So, the next one I'm going to put down C2H4. Okay. I'm going to put down C2H4. Let me use a different color so this don't get... C2H4. Ready? The same as before. I have 2 carbon as atom. I'm going to connect them together. I have 4 hydrogen. So each carbon gets how many hydrogen? Hopefully you're yelling at me that each carbon would get 2 hydrogen. Okay. Now, you're just counting bonds. How many bonds does carbon have? 1, 2, 3. This one, 1, 2, 3. Okay? 1, 2, 3, 1, 2, 3. It only has 3 bonds. Carbon needs how many bonds? 4 bonds. What am I going to do? Make a double bond. Okay, so what did I do? Let me redo it. So here, over here, carbon on top. Carbon had 4 bonds. That was great because we had 1, 2, 3, 4. This one right here, again, carbon had 4 bonds. We were good. 1, 2, 3, 4. Carbon 4 bonds, you're good. Now over here, 1, 2, 3. 1, 2, 3. So each carbon has 3 bonds, not 4 bonds. How many more bonds do I need? I need 1 more bond. All you have to do is just make a double bond. And you're good. Pretty easy, right? These are for hydrocarbons. Alright, let's do one more to make sure you got this down. C2H2. Pause me, do it, and then we'll go over it together. So, you attach the 2 carbons together, okay? I have 2 hydrogen. So each carbon gets how many hydrogen? Each carbon gets 1 hydrogen. How many bonds does carbon have right now? Each carbon has how many bonds right now? Each carbon has how many bonds? Count it for me. Each carbon has only 2 bonds, right? Because 1, 2, 1, 2. Okay. So it has 2 bonds. How many more does it need? It needs 2 more bonds. So what do I need to make? I need to make a triple bond. So now carbon has 1, 2, 3, 4. 1, 2, 3, 4. So it has 4 bonds. So far, so good? Okay, beautiful. Again, when you have hydrocarbon, connect the carbons together, add the hydrogens. Carbon needs 4 bonds. Carbon needs 4 bonds. If carbon doesn't have 4 bonds, make double bond and triple bond. Now, the last fun thing to talk about. This is carbon single bond. C2H4, you had carbon double bond. C2H3, you had carbon triple bond. I've exaggerated, but this shows that carbon single bond is the longest, and carbon triple bond is the shortest. And this is the longest, but is the weakest. It's easy to break that bond. But carbon triple bond, that's the strongest. It's going to be much harder to break it. So far, so good? Okay, this is a little bit of fun side note about the bond lengths. Carbon single bond is much longer. Double bond shorter. When you have 3 of them, it ends up being the shortest. But this is stronger because it's harder to break it. Okay, so again, let's go over it one more time. If you have hydrocarbons are made of nothing but carbon and hydrogen. Attach the carbons together, add the hydrogens together, add the hydrogens to carbon, and you need to remember, hydrogen makes 1 bond, carbon makes 4 bonds. Hydrogen makes 1 bond, carbon makes 4 bonds. Count the bonds, 1, 2, 3, 4. We're good. We had 1, 2, 3. Okay, we needed 1 more. I'll make a double bond. Here we had 1, 2 bonds. Okay, I need 2 more. I make a triple bond, so carbon can have 4 bonds. All right, beautiful. Really nice job. There's one more thing we need to talk about with Lewis structure, and then we're done with it. Nice job, guys, for hanging in there. I will talk to you next time.